Hello, I'm Madeleine Smith.
And I'm Jennifer Vuong.
We are undergraduate researchers in the Oregon Education Science Lab, working under the mentorship of Dr. Matthew Graham and Dr. Jennifer Huseman. Today, we'll be telling you about future thinking in science class and motivation to learn. What makes a successful student in a college science class? Do the goals students have and their confidence influence student motivation to be self-regulated learners? Research has demonstrated that when students are focused on learning goals, understand how the course is essential in achieving their future, or are confident, they are more self-regulated learners. Prior research has focused on which of these motivational factors have the strongest relation to self-regulated learning. These factors are all present within a student, but have traditionally been researched separately. Therefore, it may be more accurate to study them in relation to each other to see how they influence students' motivation for self-regulated learning. The present study used a profiling approach to identify and find the relation between patterns in students' motivation and self-regulated learning and performance in a science course.
Our study had two research questions. First, what motivational and self-regulated learning profiles do students adopt in a required science course? And two, does performance in a science class differ by profile? In our methods, students were recruited from an introductory science course at a four-year university and completed a self-report questionnaire on their future thinking, goals, confidence, self-regulation, and knowledge-building strategies. Of the 385 participants who took the survey, age ranged from 18 to 45 years old, and 68% of the sample identified as female, and 59% of the sample are white. Our survey included measures of self-efficacy, perception of instrumentality, goal orientation, and self-regulation strategies. Performance was measured with final term grades. Self-efficacy is a student's confidence in their ability to complete a task and was measured with the 8-item subscale from the Motivated Strategies for Learning questionnaire. Students' perception of instrumentality endogenous, PIEN, and exogenous, PIEX, were measured from the future time perspective scale. Endogenous perception of instrumentality is when students value a course because they are personally interested in it, while exogenous perception of instrumentality is when students are motivated because they think they must do something. Goal orientation is measured with a trichotomous framework, which are master goals to deep learning goals, performance approach goals, learning to get a good grade, and performance avoid goals, which is wanting to avoid looking less intelligent than your peers. These are derived from the patterns of adaptive learning scale. Self-regulation and knowledge-building strategies are measured with the corresponding subscales from student perception of classroom knowledge-building scale. Variables were measured with a 5 and 7-point Likert type scales.
Hierarchical cluster analysis, HCA, was used to create profiles based on multiple aspects of students' motivation and how different profiles relate to students' self-regulation and performance. The profiling approach illustrates how independent psychological constructs interact to form clusters, which are referred to here as motivational and self-regulated learning profiles. HCA was conducted in SPSS version 27. A dendrogram and icicle plot were extracted using Ward's method and squared Euclidean distance. We found that 3 profiles best explained our data and mirrored prior research findings. Cluster 1, the blue graph, represents 24% of students. This cluster had high PIEX and high performance, avoid, and approach goals. Compared to the other clusters derived with HCA, we inferred that cluster 1 represents students who are motivated by performance outcomes. Cluster 2 represents 35% of students. The mean scores for each variable were below the grand mean, except for PIEX. Therefore, cluster 2 is inferred to be low in motivation and self-regulation strategies. Cluster 3 represents the remaining 40% of students. This cluster is high in self-efficacy, mastery goals, self-regulation strategies, and is low in PIEX and performance avoid and approach goals. Cluster 3 is inferred to be the learning profile of students with personal interest in the course and who have high motivation and self-regulation. We also conducted a one-way ANOVA, and this was used to test cluster profile differences in end-of-term grades. A statistically significant difference was found between cluster 1 and clusters 2 and 3. We conducted conducted post hoc comparisons using Bonferroni's correction, which indicated that cluster 1 and cluster 2 are not statistically different. When compared to cluster 3, both 1 and 2 are statistically different.
Imirative factors work in tandem to support students' learning performance. Learning goals, confidence and ability, valuing of the course, and self-regulation strategies influence students' performance in a science course. Using cluster analysis to identify the relation between these variables, 3 motivational and self-regulated learning profiles were found. 1, students who have high performance goals. 2, students who are taking the class simply because they must. And 3, students who learn deeply and are personally interested in the course. Cluster 1 and 3 are similar, which indicates that cluster 3 is better for students' grades. While both clusters have students who are confident and utilizing self-regulation strategies, the difference in performance goals and exogenous perception of instrumentality may be an indicator of the difference between end-of-term grades for the 2 clusters. Understanding the different learning profiles students adopt can help secondary science instructors alter the course structure to decrease the emphasis on performance goals.